Unit circle part 2. We are going to look at angles that don't appear to be on the unit circle, but really are. Any angle can be on the unit circle with any given radius. What does that mean? So for example, let's say I give you an ordered pair of -1/5 and 2√6/5. So in the unit circle, we know that cosine is the x-coordinate and sine is the y-coordinate. And I'll ask you to find the value of the 6 functions. Well, you have 2 of them taken care of, but if you remember your relationships, that cosecant is the reciprocal of the sine. So the reciprocal of the given sine is 5/2√6. And when you rationalize that, you get 5√6/12. And then the secant is the reciprocal of the cosine, which is much nicer to do. The reciprocal of -1/5 is -5. And then you need to remember that tangent is sine over cosine. This looks nasty, but it really isn't. So the sine is 2√6/5 over the cosine, which is -1/5. This ends up being -2√6. Okay, and I'll come back to this in just a second. And then the cotangent is 2 ways you can look at it. Cotangent is cosine over sine. Or you can do 1 over tangent. Makes no difference. So I'm going to do it as the reciprocal of tangent. So this is 1 over -2√6. Rationalize, and you get -√6/12. Not showing the rationalization step. If you need to, pause the video and do the rationalization, work it out. Okay, I want to come back to how I knew quickly that 2√6/5 divided by -1/5 was -2√6. Notice that, okay, this is a complex fraction. A fraction over a fraction is called the complex fraction, and they have the same denominator. So you have some value x over a denominator, call it d for denominator, super fancy there, over another fraction, let's say y, over the same denominator. Well, when you multiply by the reciprocal, x over d times the reciprocal, which is d over y, you end up with x over y when you cross reduce. So I just did the numerator over the numerator, and that's going to help save you a lot of time. But wait a second, how can you say that the value of this ordered pair is cosine sine when it's not on the unit circle? But it indeed is, and this is again something that's going to help you later on down the line. So I want to go back to cosine sine. I'm just going to scooch this up here. Okay, so you know that the cosine is -1/5, and you know that the sine is 2√6/5. But that's only true for angles on the unit circle. So how is it possible that I'm just allowed to say that x is cosine and y is sine? All right, so let's go back to SOHCAHTOA for a minute. So in SOHCAHTOA, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Okay, well, they both have a hypotenuse of 5. Oh, but what happens when the hypotenuses, is that right? Hypotenuses, hypoteni, right? Hippopotamuses, oh, that's a good one. Radiuses, radii. We can have an argument about that in class. What happens though, I digress. What happens when the hypotenuse does not appear to be the same? And I'll take care of that in the next example. So one thing you need to be very, very careful of is the quadrant. So I'm going to draw this triangle. Cosine x, y sine. So that means the x, let's go back up here. X is negative, y is positive. X is negative, y is positive. That is in quadrant 2. So I'm just going to draw some random triangle in quadrant 2. I don't know what theta is, but it's not going to really matter. So the adjacent is -1, hypotenuse is 5, and the opposite is 2 root 6. Okay, so I just took the cosine and the sine and I like pulled it out of its fraction and labeled it opposite, adjacent, and hypotenuse. Well, I can use ratios. If I divide each one of these side lengths by 5, I have created a similar triangle. So if I take each one of these side lengths and I divide by 5, is my hypotenuse indeed 1 now? This is now 1. Let me just draw it again. Okay, well, 5 over 5 is 1. 2 root 6 over 5 is 2 root 6 over 5. And the adjacent is -1/5. Is the sine not 2 root 6 over 5 over 1, which is 2 root 6 over 5? 2 root 6 over 5, the sine. Is the cosine adjacent over hypotenuse? Adjacent -1/5 over 1. Is that not my cosine? -1 over 5, -1/5. Isn't that what was given? So you can make any angle you can take any angle and put it, so to speak, on the unit circle, because now we have a radius of 1, and I got the radius by creating a similar triangle. So what happens is you're used to 30, 60s, and 45s. Well, there are an infinite number of angles on the unit circle. Not all of them have to be a 30 or a 60 or a 45, right? You can figure out the measure of this angle by using geometry. So since we're here, might as well do it. Let's just use the cosine. So I can figure out that the cosine of this angle is -1/5. So from geometry, you can figure out the measure of the angle. Grab your calculator, go to mode. You should be in degrees. I think that is the default. Let me try and fix this glare. There, that's a little bit better. No, actually the default is radians, so you should be in degrees. When should you be in degrees? When should you be in radians? For right now, we will stick to degrees. For right now, we will stick to degrees. So to figure out the measure of this angle, I'm going to do the inverse cosine. So second cosine of -1/5. And the measure of this angle is 101.5 degrees. If you round to the nearest tenth, 101.5 degrees. So this angle does exist. 101.5 is in the second quadrant, which is where we said it should be. Okay, so what happens when you don't have the same hypotenuse? What happens when you don't have the same hypotenuse? Well, you can figure that out. So let's say that I give you an ordered pair, -1, -2. Okay, this is going to be in quadrant 3. Recommend you draw the triangle. When you're dealing with problems like this, you should draw the triangle. Okay, so I know that the x coordinate is -1. So my x coordinate is -1. I got that from here. This is x, y. Whoa, wait, Miss Babiak, why isn't that just cosine sine? This is -2. So wait a second. In the previous example, I said that x was the cosine, y was the sine. We labeled our triangle. Let me go back. We said x was the cosine, y was the sine. I drew the triangle. I made a similar triangle. Why can't I do the same here? And this is why. So isn't this -1/1 and -2/1? Let me just rewrite that. So this really should be the same thing as -1/1, -2/1. They have the same denominator. So based on this, we would say that the hypotenuse was 1. Based on this, we would say the hypotenuse was 1. No, that doesn't work. This is not a triangle. This is not a triangle. So you actually need to figure out the hypotenuse. So this, no, doesn't work, okay? So how do you know when you can just skip? How do I know when I can just skip and say cosine, sine, it all works out? Versus here, it doesn't all work out. You're going to need to check the denominator, which is the hypotenuse. If you draw the triangle and you can use the Pythagorean theorem, like here, if you use the Pythagorean theorem, no can do. -1 squared, quantity squared, plus -2, quantity squared is r squared. So in this case, I believe r is √5. It is total coincidence that you get √5 for this example and the previous example. And from here, you can find all the ratios. So from here, the sine is -2/√5. You can figure those out on your own. Pause the video. Those are your values of sine, cosine, tangent, cosecant, secant, cotangent. Okay, let's do some evaluating using f of x, g of x, etc. Okay, so I'm going to give you, given that the f of theta is sine and the g of theta represents cosine, leave a little bit of space because I'm going to come back to this. So leave a couple lines. And I'm going to tell you that theta is 60 degrees. Okay, so again, leave a little bit of space here. Okay, I think that's a little bit better focus. So let's say I ask you to find I want you to evaluate the f of 2 theta. That is not the value of the sine times 2. This says take theta, which I gave you was 60 degrees, multiply it by 2, so this becomes the f of 120, 60 degrees. 120 is in quadrant 2. √3/2. I think that's correct. I'm trying to do it off the top of my head. I'm sure that I will get emails if it's not right. Be nice. Okay, what about the g of theta over 2? Okay, so this is just the g of 60 degrees over 2, 60 degrees because that's what I gave you. So this ends up being g's cosine. This ends up being the cosine of 30 degrees, which is 1/2. Let me go back. F was sine, so this is the sine of 120. Okay, how about, let's look at a negative. How about the f of negative 2 theta? So this is just the f of negative 2 times 60. Don't forget your degree symbols. Notice I have a degree symbol in all of these. You should too. If you write your degree symbols in your work, you're less likely to forget to write your degree symbols in your answers. And you will lose points every single time in your answer that you forget a degree symbol. So this is the f of negative 120, which is the sine. F is the sine. The sine of negative 120. I'll just sketch a quick little graph for you. Negative 120 is in quadrant 3. Negative 120 is in quadrant 3. That's a 60-degree reference. I wrote super small. My apologies. The reference angle is 60. Opposite the 60 is √3/2. And then it's in quadrant 3, so it's negative. It's imperative that you know how to find the sines, cosines, etc. You know that sine of 60 is √3/2. Sine of 30 is 1/2. And then from there, you can figure out your positives and negatives. So I told you to leave room. Now we're going to throw in a couple more functions. So let's say that I tell you that now that the h of theta is 2 theta. This is, how can that be? That's no different than saying, you know, the f of x is 2x, y equals 2x. No different, just thetas. And let's say that the p of theta is theta over 2. We need to go back and look at composite functions. Composite functions. So if I ask you to find the theta is no longer 60, I'm going to change theta now, okay? So this is no longer. Let's say I ask you to find the f times g of 4π/3. The notation, you have to be super careful. Close circle, this means multiply. So this is the f of 4π/3 times the g of 4π/3. So that is 240. If it helps you, that's 240 in degrees. So f is sine. So this is the sine of 240. I hope it's 240. Times the g is cosine, times the g of 240. 180, yeah. Okay, so that's a 60-degree reference. So the sine of 60 is √3/2. and that's in quadrant 3. So that is negative root 3 over 2. Cosine of 60 is 1/2 in quadrant 3. So this ends up being root 3 over 4. Let's do a composite where you're not multiplying the angles together. Let's do a composite. So if you have to find something like the H, open circle, I'm not sure if you can tell. This was a closed circle, that's multiply. Open circle, that's composite. So let's do the H of F of 5 pi over 6. So this is the H of the F of 5 pi over 6. Okay, so F is sine. So this becomes, I'm just going to write down here, the H of the sine of 5 pi over 6, that is 30-degree reference in quadrant 2. For those of you who are like, how is she getting that so fast? Divide by 6. So if you're converting this to degrees, I'm not sure if you remember from whichever day we did notes, 180 over 6 is 30. So this is a 30-degree reference. So right away, I know that the sine of 30 is 1/2. The question is, which quadrant is it in? So I knew this was a reference of 30. 5 pi over 6 times 180 over pi. Reduce, you get 30. That's always going to be the case when the denominator is 6, your reference is going to be 30. If the denominator is 3, your reference is going to be 60. If the denominator is 4, your reference is going to be 45. So a total of 150, quadrant 2, you don't have to draw it, and I really, really hope that eventually you won't have to draw it. If you have your unit circle memorized, more power to you. So this is a 30-degree, and I know that the sine of 30 is 1/2, and it's in quadrant 2, so it's positive. This now becomes the H of 1/2. So now this is 2 times 1/2, which is 1. Okay, last one, you're going to want your book. I'm going to do a word problem. I'm going to do number 122. Book, page 381, number 122. Okay, first thing you need to do is read that on page, the problem asks you to find, get a projectile fired at an angle of 30 degrees to the horizontal with an initial speed of 150 meters per second. How am I supposed to find the range and the height? And if you look on page 380, the bottom page 380, it gives you a couple formulas that are quite useful. And it says that the range of the projectile, that is the horizontal distance that the projectile travels. So we have this projectile, and here's the ground, and it is fired 30 degrees. Eventually it comes down. I want to know how far is it from here to here, given that I'm shooting up at 30 degrees and it's going at 150 meters per second. And the height that it reaches, so it's a parabola, it's max height. Well, this is not going to help you very much without knowing that the given formula is that the range is the initial velocity squared times the sine of 2 theta over g, and g is gravity, 32.2 feet per second, and that's 9.8 meters per second. Okay, so plug in. After you plug in, oh, by the way, this is 60 because it's 2 theta. So 2 times 30 is 60. So when you plug in, you get 1,988.3 meters. They want to know the maximum height. So the h of theta is the initial velocity, which was given to us as 150 meters per second, times the sine of theta squared all over 2g. Okay, let me make a side note here. Rarely are you going to see written as sine of theta squared. I'm not actually sure why they wrote it that way, frankly. This is sine squared theta. So again, let's plug in. After all the plugging in, you get approximately 287, and we're doing height, so this would be meters. Careful when you're plugging into your calculator that you use parentheses around the denominator. Clearly, I paused the video and did the math, and I had to do it twice because I messed up with the parentheses. And that is the remaining part of section 6.2.